Well, welcome everyone. This is the sixth seminar of the Nature Reviews Physics AI for Science and Government series at the interface between machine learning and physics. Our seminar today, Science in the Age of Large Language Models, takes its starting point from a viewpoint article that Abeba, Atusa, Sandra, and I have just published in Nature Review Physics, and which our amazing editor and organizer of this event, Yulia Georgescu, will paste a link to that article, and she has, in the chat. So let me say quickly a few words to introduce our discussion today and to highlight the need for timely, serious, and society-led reflection about the range of challenges that we are now facing amidst the rapid proliferation of so-called foundation models and generative AI systems. These technologies will undoubtedly play a significant role in the future of scientific discovery. This can already be seen across a range of results, from the detection of physical symmetries and anomalies in high-energy physics to data-driven discovery and optimization with regard to drugs, proteins, chemical compounds, and other engineered materials like semiconductors. In a sense, with a sober, tool-based and interpretively responsive understanding of transformer models and self-supervised learning algorithms, scientists could deploy these technologies as computational vehicles of observation, assay, and analysis to probe properties of complex physical and biological systems and patterns in high-dimensional biophysical data. Such patterns would otherwise potentially remain inaccessible to human-scale examination, experiment, and inference. And in a sense, generative AI may open new interpretive contexts of discovery and understanding. It is, however, difficult right now to discern the extent to which the long-term impacts of these technologies on science, both as a community of practice and as a transformative human endeavor, will be positive or negative. We currently live in a buzzy and undisciplined environment of scientific communication, wherein researchers freely partake in magical thinking about the takeoff of artificial general intelligence or the birth of autonomous Nobel Prize-winning AI scientists, instead of confronting the real-world challenges and potential harms posed by the breakneck industrialization of generative AI. I think all of us on this panel today would agree that scientists must proceed here with equal measures of skepticism, reflexivity, realism, and humility. In considering the potential benefits and harms of large language models and generative AI systems, scientists must see themselves both as members of an intergenerational community of scientific practice and, in a broader sense, as citizens, members of the public, and as biospheric stakeholders. In the former sense, that is, in the context of scientific research, teaching, scholarship, and academic publication, scientists as practitioners must consider a range of issues that include challenges to research integrity, challenges to scientific ingenuity and discovery, deriving from reliance on foundation models which draw on data from the past to generate inferences, potentially engendering paradigm lock-in and stifling novelty and originality. Challenges to research integrity related to reliance on foundation models in scientific writing, risks of plagiarism, authorial misrepresentation, and scaled academic dishonesty, risks of diminishing or weakening the writing and critical thinking skills of researchers and students due to over-reliance on generative AI tools to produce argument and text. In the broader sense, the latter sense, that is in the wider cultural, social, economic, political, and legal context, scientists as citizens and stakeholders must consider a range of issues that include challenges related to the centralization of power by those few corporations and organizations who control the means of production for foundation models and who control data and compute infrastructures, challenges related to algorithmic bias and discrimination that arise in these technologies from the existence of harmful social stereotyping and demeaning, oppressive, disempowering, or discriminatory behavioral patterns in the training data, challenges related to the replication of hateful, harassing, or abusive language, challenges related to value lock-in, challenges related to data leakage, challenges related to the exploitation and elimination of skilled human labor, challenges related to the deceptive anthropomorphization of conversational agents or other human-like interaction platforms. In any case, this is just a sampling of the range of issues that we hope to explore today, and that we really do stress are exigent and in need of immediate critical reflection. So quickly, let me give you a few housekeeping items. Please note that the session today will be recorded. During the session, only nominated panelists can speak or share the screen during the session. And so we'll sort of hand off to each other as we go along. We are reserving 20 minutes for open discussion and audience questions. Attendees will be able to submit questions and comments via the Q&A function throughout the events. The first name of the speaker that the question is addressed to should be included if you want to include a specific speaker in your question. There's an upvoting function, so you can upvote questions by clicking the thumbs up icon if you are especially interested in hearing the answer to one of the questions. Please also note that you'll have the option to submit your questions and comments anonymously if you wish to do so. There's also, I should note, a closed caption function that you'll see on the screen. So please feel free to use that if you choose. So without further ado, let me introduce our brilliant group of panelists today. First, Abeba Berhane is a cognitive scientist researching human behavior, social systems, and responsible and ethical AI. She's senior fellow in trustworthy AI at Mozilla Foundation and an adjunct assistant professor at Trinity College Dublin, Ireland. Atoussa Kassirzadeh is a philosopher and ethicist of science and emerging technologies, an applied mathematician and engineer. She's currently a tenure-track assistant professor and a chancellor's fellow in philosophy, and the director of research at the Center for Technomoral Futures in the Futures Institute at the University of Edinburgh. Her research work is focused on the implications of machine learning, in particular large language models and other models for science, society, and humanity. And last but not least is Sandra Wachter, Professor of Technology and Regulation at the Oxford Internet Institute at Oxford. She researches legal and ethical implications of AI, big data and robotics, as well as internet and platform regulation. At the OII, she leads and coordinates the Governance of Emerging Technologies GET research program that investigates legal, ethical, and technical aspects of machine learning questions. So let me just start out by maybe posing a general question for everybody before we look at some sort of more detailed questions. So I guess the first question that I want to ask is, what do you feel are the greatest potential benefits and the greatest potential risks of integrating large language models and generative AI into science and research and innovation practices? So what do you see as the greatest benefits and the greatest risks? So why don't we start with Atoussa?
Yeah, thanks. So if I want to start with mentioning my kind of guess of the greatest potential benefit, I'll definitely mention the possibilities that these language models and other generative models introduce in the generation of hypotheses and exploration of possible experiments, like experimental design. So they can kind of like search. These models have the ability to search on a very high dimensional space of possibilities. We as humans do not have that search capacity in some contexts. And so they can help us scientists as tools that suggest some hypothesis. And maybe for a specific like PhD student scientist, it would take like 10 years or 5 years to formulate an interesting hypothesis. But with these systems, we might be able to kind of generate a list of interesting hypotheses. Obviously, if certain conditions are satisfied, proper prompts are used, proper data is used for training and fine-tuning and all of that. So I think that kind of capacity or that kind of assistant capacity that these technologies introduce can be super interesting and exciting for scientists. loads of problems or possible problems, as you mentioned, David, and I think we're going to explore throughout the rest of the panel. But if I want to mention one main concern, that would be the possibility of the propagation of falsehood and non-existent material into different scientific reports, scientific papers. And again, remember that physics, as one of the most mature sciences, is this very, very complicated science already. So we have all this experimental data, and different communities of physicists are doing their own complicated kind of physics research. And so I think these technologies add a very kind of high stake, if I may say, kind of addition to in terms of the generation of knowledge, generation of literature. And so we don't have proper tools to fact check all of these resources, suggestions, summaries that these technologies can introduce. So I think the possibility of the propagation of falsehood and non-existent material in different scientific papers, but also scientific communication to public more generally is a great risk.
Thanks. Why don't I turn it over to Abeba?
Thanks, David. Yes, excellent point, Satusa. And I agree with everything. And I will add that, well, first of all, the question is always posed are what are the benefits and risks of generative AI, large language models, or whatever you name it. And I find it interesting that it's always the benefits that are first mentioned or that we are asked to list. From where I'm sitting, from my point of view, I see so many more limitations, so many more harms, so many more issues related to large language models. I think we should start with limitations, then benefits. Having said that, yes, in terms of limitation benefits of large language models within scientific practices, I think before we delve into that, maybe it might be helpful to kind of think of that question as containing 2 points. So the first one is the understanding that when we think of large language models in scientific practices, there is this misunderstanding that equates large language models to as science, as science, the very practice of building models or the model itself as something scientific. So this is one. The second one is, David, as you mentioned it, the misconception that the model itself can be a scientist. You mentioned, are we at the verge of a large language model or some kind of AGI agent that is about to win a Nobel Prize? So yeah, so the first one, mistaking this engineering brute force, of course, excellent achievement, as something that is scientific, and the second one, treating the thing itself as a scientist. So I think both of them are problematic. The first one, when you think of, we are all scientists, and most of the audience would be very familiar with at least the general idea of how scientific practices work. The very idea of science itself, it's extremely transparent. When you carry out scientific research, you are very clear about your hypothesis. You outline the processes that you followed, the methods that you followed, the data that you used, the kind of analysis that you carried out, and your findings. So this is, the basic idea of scientific practice. None of this is present in the current large language models that are being, whether it's closed sourced or open sourced. Relatively, of course, open sourced models are a little bit more transparent. We can audit them. We can ask some of the questions. But in general, this is missing. So I don't see how, the process of developing large language models follows a scientific practice. It doesn't. And the second one, thinking of large language models themselves as scientists also gravely mistaken, because the model, and Atoussa, you have put it beautifully, how the way it works, how it searches for patterns from vast amounts of data. So it's at the end of the day, it's a model, it's not a human being, and science is a human practice through and through and through. As scientists, when we interact with the model, it's a one-way interaction. We are probing the model and getting an answer. The model is not, improvising. The model is not another, another active participant in the scientific process. As scientists, when we go into, asking a certain question, we have, our own histories, our own interests, our own motivations, political views and backgrounds that all influences in what kind of questions we ask, in the kind of things that we are interested in, and in the kind of things we end up investigating and finding and putting out to the world. So the scientific process is completely not detachable from the person that we are. Large language models, on the other hand, are not attached, don't have any motivation, are not interested in finding anything, discovering anything. It doesn't care whether it finds a novel, it has a novel finding or not. So that's also another mistake that is worth clarifying. So having said that, coming to the limitation, this without the clarification of this misunderstanding, we often fall into buying over hype. We often fall into thinking that these models are scientific agents themselves, or that they follow the scientific process, and with this keeping these clarifications in mind helps us in then exploring the kind of things that Atoussa was talking about, the fact that they are brittle, the fact that they hallucinate or they fabricate text that seemingly seems factual, but it's but in fact doesn't exist, and also in treating them as scientific agents, accountability is completely dissolved. When we put something out, we are accountable. If something is not correct, we take responsibility and we retrieve it. So these are the not limitation, but the cautions that I think we should take when we are approaching large language models, either as scientific agents themselves or as something that follow the scientific process.
Thanks, Abiba. Let's turn it to Sandra. Sandra, what are some of the risks and potential benefits around the technologies?
Yes, I can actually only just agree with everything that was said, wholeheartedly agree with everything that was just said, and just add to the list of problems, if you will. To my background, I'm a lawyer and I work in questions of legal governance and ethical considerations. So like I live on the intersection of the social sciences and humanities, if you will. So that's also science, but maybe a different type of science that people usually think about when they think about science, whatever that means. And so in terms of like the benefits, I thought to myself, well, what would it be that I could use such a system in my practice as somebody that lives somewhere between the social sciences and humanities? And I thought I would compare it to a very unreliable research assistant. I think that is what I can use it for at the moment, which would mean that if the model is, again, trained on data where I know what the data actually is, and that's a different problem. So if I would know, for example, that it was trained on peer-reviewed journals on a scale that is overseeable, I would have an understanding of what's in there if it's not Reddit and Fortune and Wikipedia, but actually published journal articles. And then I could use it, for example, to help me write a summary of what's currently being debated, right? And that would help me give an overview of what the field's currently doing. I could get an overview of what the current trends are, but with an unreliable research assistant, I have to double check still. So it buys me a little bit of time, but it doesn't actually do that much. And again, I would really need to know where the research assistant gets their facts from. And so it wouldn't actually do that much at that particular instance. So it's a little helpful, but like not groundbreaking. I don't necessarily feel like that my field is necessarily going to benefit at the current stage a lot from it. On the other hand, I see a lot of disadvantages. And so one of the, again, fully agreeing with everything was said, an additional one that I could see is that if large language models are being used for peer review, because, you know, if you're in the community, peer review is something that is really important, but takes a lot of time. So there could be an incentive for academics and scientists to wanting to outsource that type of labor. And that can just really lead to reinforcing old beliefs about society and reinforcing certain stereotypes and freezing the status quo, because as we heard, that thing doesn't care about knowledge. It can't care. Like there's no capacity to care. Like it's a thing, it's a calculator. It's a very dumb calculator, if you will. And so it has no concept of ground truth. It has no concept of novelty. It has no concept of what groundbreaking ideas actually mean. It only has the past to look at. And if you want to be groundbreaking, you have to break away from the past, right? So the thing that peer review is supposed to do, elevating the novelty of an argument, is exactly the thing that it cannot do, because that's the limitation of it. Like it's not designed to do that. And so there I see a lot of problems if peer review is then being outsourced, that we're just going to freeze a knowledge status quo that is not very good. And we know this already. Like if you look at biology, for example, there are very old conservative stereotypes of what gender, ethnicity means, how biology is affected, nature versus nature discussion, and how communities of color and or women are being thrown up at peer review every time they want to challenge that type of dogma. Well, what do you think is going to happen if an algorithm is going to do that, right? It's not going to say, oh, actually, all those white dudes were wrong. They're going to say, no, what he said, right? And just going to reinforce that. But we're going to think, because it's such a smart, large language, intelligent machine, that it actually knows what it's doing. So I think that can just be really a big, big hindrance to coming up with new ideas and really pushing the boundaries of knowledge if we allow peer review to be done by those dumb systems.
Amazing. Those I think are all really sort of big picture comments. Atusa, I wanted to ask you something that came up when I was listening to Abeba. Abeba made a nice distinction between thinking about large language models as science and thinking about large language models for science, right? And so if we start with the as science part and we think about the challenges, right, that are being presented to us in terms of the science of large language models, which is to say, you know, we're facing, you know, lack of transparency, challenges with replicability and reproducibility, opacity in the algorithms, so not or in the models not being able to, you know, discern where or why inferences have been made. I guess the question is, in light of the challenges faced by LLMs and generative AI as science, can we even take that next step and think of these for science?
That's such a wonderful question, David, and thanks, Abeba, for putting that out, because I can speak of my own experience. So before I studied philosophy and ethics of science and technology, I was studying applied mathematics. And so this term applied mathematics, the area in which I got specialized in some places it's introduced as decision sciences. So it's a science. So when you go to different kinds of conferences, you perceive yourself as a decision scientist. And then at some point, people started naming themselves as data scientists. But sometimes people would call us applied mathematicians or operations researchers or computer scientists, right? So term science, the way it is used here, is very, very, very different with the way the term science is used to describe physics, right? Because physics is this mature area of inquiry, like through centuries. Many different people, different scientists from different parts of the world, right? From Egypt, ancient Persia, India, like Africa, like the Western world. They kind of like had this very specific question. We want to understand the nature of reality where we are living in. We want to understand whether the world is made of materials, whether there's one kind of material. So the questions were kind of like clear, they were changing their form. Like that's a sort of issue that philosophers of science have been grappling with. Like, so the questions were kind of changing, but somehow they were trying to grasp something about our observation about the nature of reality, right? And there are a spectrum of different views. Some people say even science of physics cannot tell us anything about reality, right? If you want to accept some anti-realist stances about reality. Some people just say that, okay, we kind of use science of physics, it tells something to us about reality, and then what the building blocks of reality are changes by time. Now, when we look into computer science or data science or decision sciences, things are kind of different. I think in those areas, people mainly refer to the term science or use the term science to kind of say, we are using some systematic endeavor, we have some data, and then we have lots of mathematics, lots of mathematical knowledge, lots of mathematical proofs, lots of information about theories of computations, learning theory, all of that. And when we put all of them together, we end up developing this very sophisticated mathematical and computational tools. I mean, as Sandro mentioned, like we really can think about, if we stop really anthropomorphizing with language models, we really can think about this language models as being super, super sophisticated kinds of calculators, right? So they can search through this like multidimensional space that we can search and just provide information to us super quickly. And then some of us get super excited and say, wow, they have feelings or they understand meaning. Some other of us like look into what they're really doing from a very mechanistic perspective and mathematical perspective. So I think I kind of like resist using the term science for language models in the same, like in a way that we use the term science to kind of describe the activities or practices of physicists. And again, due to various disciplinary motivations, you know, computer scientists call themselves science, but that has a very specific meaning if you are a computer scientist, right? But when you come out of the discipline, some people think that, oh, because large language models are being developed by computer scientists, so they are also kind of a science. And I think that's really wrong. And I think it's a responsibility, and I really want to emphasize on that it's a responsibility of computer scientists and those who are developing these models to kind of clarify and the public and like to do conceptual clarification, and just don't use these terms in a very, very irresponsible way. I think it just hurts the fabric of society and the way we think about scientific knowledge. So that's kind of like my stance on whether these systems are science or not. I would say no for various reasons. But as I think Abiba and Sandra mentioned very nicely, we use them to kind of do science, right? And then to do the practice of science, you go through multiple tasks, right? You might need to just understand a little bit about the topic, right? So you just want to start exploring what is cell biology. You can use a language model to a little bit learn about it, right? Or you want to kind of like get a summary of some articles and papers, or you want to kind of like do very complicated science. You want to know if you use AlphaFold in order to kind of do drug discovery for a specific kind of cancer, like how you should do that and what are the risks there, and whether you really can have like meaningful, very low risk kind of drug discoveries. In those areas, I really don't think that at least the current language models that we have can do those kinds of activities in like this complicated activities. And I think we all kind of came across this in the viewpoint. And I think one, like as a person who did work on philosophy of science, when we look into the practice of scientists, they make loads of value judgments. Many value judgments become normalized for scientists who practice those scientific endeavors. And many of these value judgments are implicit, right? So the scientific community knows about them because they started doing science gradually and they learned in different conferences, different venues. And again, as Sandra was mentioning, these systems are not really like this embodied, and Abiba also was mentioning, they're not this embodied entities that go to conferences and hang out with different scientists and learn from them. No, they're just like this sophisticated entities that do search and provide very cool outputs, like things that we call them very cool outputs, right? And so in that sense, I think we need to be super cautious and careful that these systems can assist us in doing some things, maybe as maybe like bad or irresponsible or non-reliable assistance. But we shouldn't just like overgeneralize and say, okay, now because they can do something small here and there, now they can do science. I think we really have to resist this tendency.
So I want to maybe turn it back to Abeba first and maybe ask a two-parter. So thinking about what Atusa said, I know you've written a lot about not necessarily just models, but modeling, right? And the way that models are applied to modeling our world, our human world, our biophysical world. So I'm wondering if you could sort of think out loud about that kind of potential gradient of limitation when we think about what is being modeled with these types of systems first. And then a second part of the question is, in a different direction, clearly one of the big problems with these models is the volume of data that's needed to train them, and the challenges to thinking about, in a sense, properly pre-processing the data and ensuring that the data is sufficiently, to the extent possible, bias mitigated and all of these things. So I'm wondering if one could think of paths forward there. How could we approach these large-scale data sets and prepare them so that there can be responsible pursuits of foundation model building?
Thanks, David. Excellent questions. So the first one, what is being modeled? So the general understanding, especially within, the corporations that are putting out large language models, or even the general, like natural language processing community, this kind of academic activity, or the idea of gathering text data or even voice data and building models is seen as something that captures human language. The idea is like you are modeling human language. However, this is where my cognitive science background is helpful, I find, is that we know that from critical perspectives in complex science, in active and embodied cognitive theories, we know that human language, human communication is much more than just text or voice data. Even here, as we are sitting on the same panel over Zoom, it's not just our utterances, our just voice communications or the text we type that is helping us understand each other. That's guiding the conversation. It's the nods we make, it's the gestures, it's the facial expressions, it's the very body that we embody. It's the comments we make, sometimes that are really nuanced, even the things that we don't say, that we understand each other, have meanings. So human language is much more complicated, much more diverse, much more active, and has so much historical, cultural, and background baggage, because we understand each other, because we have so much background knowledge with each other. We have so much in common. So all that is taken for granted. So all that constitutes human language, not just the text in the voice or the utterances we make. go to large language models. When we are building a model, we are using mainly text data and maybe even sometimes voice data. So even from the data we are using, we are not capturing the entirety of language. To begin with, we can't capture the entirety of language in data sets because it's something that's fleeting, that's changing. So even if we can assume we have the perfect data, which doesn't exist because all data is full of problems. Trust me, I'm a data set auditor. That's not scientific though, it's so you know what I mean. Anyway, even if we can assume data is perfect, even if we can assume the model, architecture, the fine tuning is perfect, what we end up modeling is just a fraction of human language, a fraction of interaction. We are only catching a snapshot of a moving target. So from that perspective, even if we assume everything is perfect, we are not really capturing human language. We are capturing a tiny bit of it. So moving to your second question, David, about the data sets, these huge corpuses, and the issues that are related with them and how do we mitigate them. So I have been doing audits, but mainly for image data for computer vision systems. But now that with these, generative AI and these, general purpose, I say this with a quotation mark, models, data is just not, text or audio or just images. It's become multimodal. Data comes in like text and image pairs or other pairs. So we have to, I have to also look at text data to some extent as well. And we have current work actually that's in progress where we are auditing a multimodal data sets, a huge one. So we are looking at the text that comes, this is the alt text that comes with images. This is data sourced from the internet. And time again, you find that these huge data sets contain racial slurs, contain content that shouldn't be there. They contain content that is derogatory of, minoritized communities, minoritized identities. So the data set, first of all, we with corporations such as, Facebook or DeepMind or Google that often kind of close these models and data sets, we have no idea how large the data set is. Sometimes they mention the size of the data set, but we have no idea where the data set comes from, how it was organized, how it was detoxified, the process, the steps they took to clean the data set, because any data set that comes from the internet will always be problematic. You always have to work to make it better, but we don't have any clue how those steps, what kind of measures have been taken with closed data sets. With the open source data sets themselves that we can get access to, we can see time and time again, it's full of problems that then ends up with a downstream impact in models trained on those data sets. They necessarily pick up the patterns that are found in data sets. So the outputs tend to be discriminatory, derogatory, hateful, and harmful. So the data set itself is problematic. And how do we move forward? There have been so many suggestions, and there is no bullet, there is no golden, there is no bulletproof. There is no one clean solution. And the more I look into the data sets, the more I realize if your data set is too large to audit, maybe don't have that large enough a data set. Maybe that's one of maybe that should be a principle we should adhere to. Then if we can audit it, then if we are able to, get into the data set and see what's in it, then we can make various corrections that are possible.
Great, Abeba. We're moving now to our Q&A. I do have one last question for Sandra that I'll ask, and then we'll launch into this great list of great questions. By the way, feel free to add anybody who's watching. Feel free to add questions and upvote those that you're interested in hearing answers to. But Sandra, I wanted to ask you a question really about the political economy of science and research and innovation, and how the sort of political economy of foundation models and large language models might set the direction of travel and the agendas of research communities, right? So what we're seeing now is a really kind of radical centralization of power in many ways, with very few companies being able to, and organizations being able to develop large language models. This has also sort of been accompanied by a kind of a breakneck industrial revolution with the models, right? So rapid commercialization defined by commitments to assetization of human functions, profit optimization, unlimited accumulation, these types of things. And so I'm wondering, in light of corporate capture and sort of private sector capture, how can we think of ways in which the scientific community can kind of stay independent from those types of influences, or is that a bad question? Is that not even possible?
No, I think it's an important question, and it's a question that, again, probably where we have no silver bullet to solve it like immediately. But the first thing that you said is really, really important, which is, let's not use those systems to outsource critical thinking. Like, that's the one thing I will never want to outsource to a machine. That's the biggest mistake that we can make, because how is a machine supposed to be doing that? If I'm showing you a picture or a painting, right, and you look at it and I tell you, is this convincing? It's like, yeah, this looks great. How do you know that it is missing the color green, for example? Like, how can you spot that omission? You would need to know what to look for. You would have to have critical thinking embedded in your brain to know what to look for, to find omission, to understand imbalance in the literature and how certain voices are elevated and some are being silenced. And if you don't have that capacity, you can't actually critically engage with the text. And that is the foundation for coming up with new ideas. So outsourcing that is something we should never be doing. However, and that's the question the political capture is, I see a really big threat that this will happen. And this is not necessarily the fault of LLMs, it's the fault of the ecosystem in which science has to live at the moment, right? So there is extreme pressure on science and on academia to publish as much as possible, as fast as possible. If you're living in the UK, all the universities are currently on strike because the working conditions are unbelievable hard, unmanageable workloads, really bad pay, pensions are being cut. So people are in a situation where they actually have to publish for their life. So rather than looking at quality, they're looking at quantity. And there it is, that wonderful LLM thing that promises to cut corners for you in a way that helps you to increase output. Right. And so I can see that people will be tempted to use that because what other opportunities do they have? So the solution there is, yes, we can think about a tech solution there and like have a codes of conduct and have, for example, the journals mandate that you have to say if you had used this technology in order to write something. Yes, that's all fine. But the ecosystem needs actually addressing. You need to think about the fact that government funding is being cut left, right, and center for science, that we have to constantly, especially the humanities and especially the social sciences, have to consistently and constantly justify their existence, right? That if you want to advance in the career in academia, what counts is how many papers you have and how many citations you have. That's not a proxy for merit or scientific achievement. It's a very cheap shortcut for nothing in reality. And so I think what really needs to happen is to change the scene where people can actually do the thing I want them to do, which is critical thinking, sitting down, checking the footnotes, opening the paper, not trusting the chat, but then actually do the work and being rewarded with that rather than being put under pressure to just produce like a printing press, right? Bigger is not always better. Better is always better.
Fantastic. And I'm gonna direct a question back at you now from the audience. And this is really about the comment that you made about unreliable research assistants and the analogy between large language models. And so the question is, what kind of features other than source quotations could possibly make it more reliable, would make one of these models more reliable, given that the AI has been fine-tuned with peer-reviewed papers? So, you know, what might be included to improve the reliability of these models in their training and fine-tuning?
So like Emily Bender, for example, wrote a wonderful paper, I think in 2020 or so, where she talks about data statements. I think it's what it's called, what she's calling for, which is very akin to or complementary to the work that has been done by Timnit Gebru and data sheets and data sets and Margaret Mitchell and all that great community, where it's really about like transparency and trying to figure out what is in there. And like we just heard from Abiba, if it's too big, then maybe don't use it, right? If it's too big, that like the idea is, oh, it's too big, that's just how the cookie crumbles. And it's not. The cookie doesn't need to crumble that way. Maybe scale it back and make it in a way that you understand what's in there. And so that would mean that you have the ability to put peer-reviewed papers in there. But again, coming back to the color green painting example, you also need to know what voices are not in there, right? Because if I'm just going now to everything that's peer-reviewed, that's not perfect either. Like I usually open my classes with my students by saying, just because something is published doesn't mean it's right. That's how I open every class that I have. Just because it's published doesn't mean it's right. And so you would need to actually have really thoughtful curators that think about that in detail, what is actually missing and what needs to be brought in, because otherwise you're just going to have a very skewed mirror yet again. And so that's just really something that needs to be doing, again, very counter to the main promise, which is faster. Let's do it. When actually what you need to do is be more thoughtful and more careful. So the opposite is what needs to be done to what's being sold at the moment.
So I have a question from Levan, and it's a difficult, wonderful question, and I think so. Let's all try to think through it. I want to say something about it, but I'll withhold. So the question is: thus far, the discussion is focused on LLMs as they are today. Some of the objections towards LLMs seem solvable in principle, like training data bias, right? Or, I mean, one can think of other ways that one could redress transparency issues or other issues that we brought up. I mean, it would be great to hear your opinion on the usefulness of future LLMs, one perhaps augmented 10 times and improved a lot. Is there something about the nature of LLMs that would make them fundamentally non-usable for science? Or is it just that today's models are just not there yet? So what I think it's a tricky one, but it's asking us to think about that. Is there just something that challenges the science of, or the use of LLMs for science, principally, Atoosa?
Thanks. Yeah, that's a really great question and a complicated one. And I'm not going to resolve the problem, but just suggest some thoughts. I think, as Abiba mentioned very correctly, we should never forget that scientific practice has been grown out through many different centuries. So there are lots of historians, sociologists who study the evolution of science, right? And that's a very, very complicated process, right? There has been loads of political reasons, social reasons, lots of maybe scientific reasons that have motivated the growth and progress of science in one part of the world as opposed to another one. And I think one actually maybe issue that we see with the current large language models is that we're going to observe a kind of a cognitive polarization. So the scientists that are in parts of the world that can have access to these technologies and can really do use them, as their assistants, they're gonna produce more and more paper. They're gonna explore possibilities, produce hypotheses, get more funding, right? And on the other part of the world, we have still a kind of a horrible digital divide. There are lots of people in the world who still don't have access to proper internet, right? So you can imagine that these technologies cannot really help them to kind of like do science, right? And I think those kinds of people, if we push these LLMs forward into science, and I think this is the path that we've taken, and this is the path that we are going down, we are going to see this gap like further and further. And I think we are going to, at some part of the world, see some sort of scientific results that maybe only make sense to the scientists who are very much used to the use of these complicated language models, right? Because for them, it feels natural, it feels okay, it feels good to use it, right? Like the goal is just to produce and go further and further. But I personally, as a philosopher, think some of the scientists or some of us are going to lose the whole vision of what does it mean to be a human, to do science, what is the purpose of it, right? Because we are ending up automating so many things, and then these systems are very opaque, and as others mentioned, the data sets are super huge. And as the person who asked this great question also said, these things are going to get intensified through time. So it looks like we're going to end up doing some kind of science, and very advanced science. And I'm not sure if we take away human out of it and get super excited about the automation, it's not clear what would be the meaning of that kind of science that is being produced. And I think that's a really good question for all of us to kind of reflect on and think about the more we are using and getting used to the use of these technologies.
Amazing. We are actually winding down to the final minutes. So let me take another question, and maybe I'll direct it at Beba or Sandra or both. So I'm going to combine two of the questions, actually. So this is really a question about how we've kind of been revolving around some of the shortcomings and risks, and not really talking about some of the potential benefits. The writer talks about how there can be something said for productivity growth in the plethora of tasks like literature review, text summarization, and implementing scientific software that are a huge part of the daily time expenditure of scientists, especially grad students. So thinking about potential opportunities to say, eliminate mundane tasks, or how might the sort of potential productivity gains, if you will, transform the practice of science? That's really the question. And to relate that to another question, what does that mean for the day-to-day practice of science? How will these LLMs, if used beneficially, if used for a good purpose, change the practice of science? Beba?
Yeah, sure. So these two questions are actually kind of related to the previous question, which is let's also talk about the benefits, not just the limitations. And actually, I'll start with kind of addressing one of the questions, just to add to what Atoussa said in the previous comment, and I'll move on to the current question very, very briefly. I know I'm aware we don't have that much time. So one is like, if we can mitigate issues such as data bias, what are the benefits then? So mitigating issues or fixing data sets is not an easy task, because at the moment data sets are millions, now even billions. For example, the current open source data sets, or the data sets that are being used to train these large models, are like 4, 5, 6 million image text pairs. This is huge. In order to audit this, in order to even just look at a fraction of it with a human in the loop, this will take you years. So these are not issues even from a logical, pragmatic point of view. These are not issues that can be fixed. And then you go into the conceptual philosophical discussions of what is representative, what is fair, what is just, and there is no clear straightforward answer. So the issue of data is not something that can easily be solved and then we can move on to the next question. And the other one, I'll just generalize the second question, which relates to your question now, David, is focusing on how it can be used in day-to-day lives and generally the benefits. So I think it's important to remember that these large language models are developed and deployed and sold by for-profit, even the open sourced ones that claim to be non-profit, at the end of the day, are about accumulating financial gains. Even companies like Stability AI, which has become a unicorn company just all of a sudden, that started as a non-profit, is now estimated to be worth billions. So these models are there to make money for big corporations. So we should not separate these objectives from the day-to-day uses and dissemination of large language models, because and these corporations, which has huge capital, huge influence, and huge resources, kind of disseminate and popularize a kind of an image of large language models that are beneficial. This is what we hear, whether it's being reported in the New York Times or in the economics or in the big news outlets or in the big influential institutions. You hear again and again and again overhyped, unrealistic, deceptive comments about the benefits, with very little comment on the harms and on the limitations. So I think I know this is a very kind of unusual panel that has focused on the harms, but I think it's fair to focus on the harms. It's fair to, it makes sense. And also these corporations just decide to produce large language models. We are the ones that spend our time and resources to correct records, to audit the models they are responsible to, that they should be doing. So these are things that we have to be aware of, just as we want to be aware of the benefits. And I think I just want to end by saying that it only makes sense to discuss the things that we've been discussing, as opposed to repeating the benefits that we hear again and again and again in huge influential news outlets and venues.
Well, thank you, Atoussa, Abeba, and Sandra, for an amazing conversation. And I do hope that we answered enough of them, to answer enough of the audience questions to make it more of a dialogue.